All right. All right, so let's just do our basic functions. So you should have the exact same thing here. So just type equals on page 1, and let's practice using the average function. So average type. So then you can type in the numbers and hit commas, or you can highlight an entire column. So let's say I want to find the average height of all these students, right? This is student 1 through 23. So now there's my height. Just press enter. And press equal, variance, VAR. See how there's variance P and variance S? This is a variance for a population and variance for a sample. If you don't have any statistics background, that's okay. Just remember that population means you have all the data. For example, if I had the height of everyone in San Antonio, that'd be more of a population calculation. But if I took a sample that represents San Antonio, then that would be sample type. So you would use sample because this is just a few people, right? So this is not a population. And if you calculate by hand, these formulas are different. That's why there's two functions. Just highlight it like we did before and press enter. So there's the variance for a sample. So I'm going to put a sample right here. And if I can't see it, remember last time we said you can extend them so you can read the box. Okay. Now over here, we will do standard deviation. So standard. Nope. Let's see. Let's see deviations in here. STD. Ah, here it is. STD. So standard deviation for a population and sample. So just hit the sample one, highlight, enter. Okay, and then we can do a total, right? If it equals sum, so I want to sum a row or column, you use that command, the function, and highlight column or row, press enter. So here's the total height, total of that column, etc. Okay, so nothing too crazy, right? Let's see. Also, the next thing, let's see. Yeah, here it is. So if you wanted to sort this, I'm not saying we should. I'm gonna just show you how to do it. These are already in order by student, so you would not want to rearrange this. But let's say you wanted to learn how to sort. So you highlight the column or row, and you can do sort by right-clicking, do smallest or largest, largest to smallest, etc. So I can do sure. Oh, nice. It actually rearranged the student IDs. Interesting. Did it change anything? No. Now I can highlight, sort, largest to greatest, and I can undo it by Control Z, of course. So Control Z twice to get back to what I started with. Okay. Now let me show you something that we're going to need in a moment. So hit File, and then go to Options, and then you will go to Add-ins here, and then you will have to add the Data Analysis Pack. So that's going to be this one right here, Data Analysis Tool Pack. So just click that and hit OK. Should do it. I'm going to do it again just to be safe. Options, add-ins, data analysis tool pack. This time I'm going to hit go because I don't think it worked. Yeah, go works better. Analysis tool pack, euro currency, sure, I'll add all three, whatever. Okay, and if you did it correctly, when you go to data, there should be a data analysis options somewhere. All right. Were you guys all able to do that? Because it's going to be required for the next 4 examples. Is there any question on setting that up? You also need that for your homework.
Can you show us where you got the data analysis button? Just under the data tab and it's all the way over, or did you have to add that one too?
Yeah, what I just did adds this data analysis button. So you go to File, and you did the options already, and you went to Add-ins,
Yeah.
and then you click the tool pack, and you hit Go.
Oh, the VBA. Okay. I had there's 2 tool packs under.
Yeah. Either way, it just takes you to that menu.
Oh, okay.
You just want the first one, the regular one.
Okay.
So once that's checked, it should appear. Okay. All right. Let's move on. Do some actual analysis here. But let's see here. Okay. You guys have any questions on the averages, variances, or standard deviation? All right, because I'm gonna move on. I'm gonna skip this example and do something more complicated. Let's see here. Yeah. So what we're gonna do is do regression from the data analysis tab to figure out if rainfall will affect how many umbrellas are sold. Apparently, I'm missing the data value there. Shoot, let's put 13, I guess. I guess I deleted that by accident. I don't remember. Anyway, so logically, it makes sense, right? If it's a rainy month or rainy year, I should be selling more umbrellas, correct? Just in general, like if I have an umbrella shop, or you just notice people are buying more umbrellas, that does make sense. But we cannot assume that these are what's the word? That one. This is we do not assume that rainfall is the cause of the umbrella sold. Right. So in statistics, we talk about correlation does not imply causation. Now, correlation kind of hints at it and basically tells you that we should do more research. That, yeah, it looks like there's a pattern here, and we should look into it. That's what correlation will tell you. So I know logically as humans we see, oh yeah, this probably does affect this, probably, but I can't prove it without further study. But anyway, so what you do, let's see if this works. I'm gonna highlight all these guys here. See here, click data analysis, and then you will go to. No, I don't know if I want to put the link there. That should be fine. Let's see. I may need to adjust the selection, but so hit regression and check the labels. Then input y range will be the y is the independent variable. I'm sorry, the dependent variable. X is independent. So this is the part where you gotta remember your basic algebra back in functions or college algebra or high school algebra. Do you remember what it meant to be independent or dependent? And if you don't, that's okay. I mean, sometimes the idea is a little weird. We might just think of it as, well, X is independent, and that's all we don't think too deeply, right? We just assume it's always X. But what does that mean? So to put it in real life terms, right? rainfall is independent because it's gonna rain regardless, right? Rain may affect umbrellas, but me buying more umbrellas will not make it rain more. Do you see the difference? And rainfall is X because it's not affected by the Y. So I would say, okay, for the Y, it should be all these guys. And then you click the X input, and that should be the independent variable, which is the rain. Okay. Also, it'll tell you where do you want to output this. So make sure label is checked, and then decide where I want this to appear. So I want all the information to pop out, I don't know, down here, I guess. Okay. You can also tell it to do a line plot for you, a residual plot if you want. You can get all kinds of extra stuff. We're probably not going to use any of this. But I'm just checking it just in case. It's helpful. Just make sure that these are in the right place. Hit OK. And here are our statistics. Okay, so we did a regression on 2 variables. So this is also called a simple regression because we're only using 2 variables. It's something very simple. It's not complicated. It's not doesn't have multiple factors. It's just one factor: rain impacting umbrellas. Right? You could have an example where you have I don't know a discount or a sale, rain, or I don't know, maybe good marketing or whatever. All these factors could affect how much you sell. So that would be a multilinear regression when you have multiple factors. But right now we only have one. So let's figure out what the hell this means, right? So basically what this is doing is finding creating a slope and intercept that goes through these points as close as possible and creates an estimate, the predicted values, right? So down here, these are the predicted values. So basically it's saying that it's estimating that this is what should happen based on this data, right? So as you can see, the actual umbrella sold is not too far off from the predicted. You see this? So what this model can do for you is predict into the future. So like what will happen in, I don't know, March or April after this year or whatever. So those models are good for. Of course, some models have different limitations. Now, if you scatter plot, let's see if I can zoom into this. Maybe not. Okay. So the blue ones is what actually happened in real life. Right? This is what happened. How many we sold based on the rainfall. So rainfall went up. As you can see, my umbrella sold also kind of went up. And there's a linear trend. So the fact that there is a trend of some sort means that the model is linear. So the next thing when you look at, what does this mean right here? So the R-square value is telling you how good of a linear approximation this is. So basically, the closer this is to 1 or -1, 0, if you're closer to 0, that means it's a bad model, by the way. So if it's close to 1 or -1 right here, let's see here, highlight this guy. This is telling us how linear is there a linear relationship between rain and umbrellas? That's what this means. The closer to 1 that is, the better. Okay. Ready? And then there's also amount of error because it's not perfect, right? It's a predictive model. As you can see, it's close, but it's not quite right. And we saw the predicted values here. Some are close, but some are not so close. See how this is like way off? Although I did make that number up, so that's probably why. But these are a lot closer. See that? Anyway, now the next thing is so basically this is what this did is create a let me see if I can insert a text box somewhere. Type in some info. comment. There's stupid text box. That was an insert. Oh, here it is. It's right in front of me. I'm clicking text box just to make a little note here. Okay, so what this model does is create a y equal to, it's kind of like mx plus b. It's just in statistics we use y hat. Let's see if I can make that symbol out here or not. Maybe. Oops. No, we can't. We can only do it on a word, I think. Zoom out. Okay, sorry about that. That command does not work on this Excel. Maybe I can insert the equation editor. Yeah, that's not right. Okay. Maybe it'll work. We'll see. No, I don't think so. Anyway, so usually in your calculator, if you use your graphic calculator, they'll have AX plus B. So they call this A the slope and B the intercept. And they call this Y a predictive Y, which they put like a little caret on top. I just can't put the symbol in right now, just because we don't have a lot of time to mess with that stuff. But just pretend there's a hat on it. Okay, by hat I mean this caret would be right above the Y. So anyway, so this yellow, these orange dots here are created by this estimated line called the predictive line function, which produced all these values, right? And how good of a model is that? It's based on this. And you can also visually see it's not too bad. The F significance also tells you that the model itself is good. So if this is a very small number, and this is very small, right? This is 0.00000083, very tiny. This is another indicator that, yeah, my model is not garbage, okay? Over here, though, are the intercepts and the, what's it called, the slope, okay? The intercept is negative 21. So right here, what you can do to refer to it, say type equals, and say my intercept is this guy, my slope is this guy. So you would write as an answer, right? My equation of this model would be 0.46331 x minus 21.7476. So this is the model that can estimate into the future of what might happen if there's more rain. So like if I make up a month that has 60 amounts of rain, you can predict it. Okay. You can predict what might happen. So you could say, all right, well, let's say I want to predict a made up month. Right. I'm going to move this down. So you can always highlight an entire row and type insert and it'll shift it down for you. So let's say I make up a month, January, February, March, I guess. And I say, you know what, there was like 200 rain that day. What do I predict? How many umbrellas do I predict that will sell at that moment? I'm pretty sure it's going to be more than 20, right? Seems like a good guess. So if March is a rainy month, what is the predicted amount I'm going to sell? So what you do is plug in that 200 into this X. So you can create a function, make some more space here. So you know what? Equals, right? My M times asterisk X plus my intercept B. So there is my estimated predicted sales for this umbrella. So I expect to sell about 70 umbrellas if it rains this much. That's what I am predicting because of the correlation that I've seen. And the correlation is linear, and it's good because of this guy here, okay? And this is significant. That tells you how good the model is. This tells you the linear relationship. This is the actual values of the function itself. And these are the predicted values. Okay? Does you have any question on what we just did? We're going to do it again in a moment, but I know I'm throwing a lot of information at you.
Good so far.
Okay. Anyone else have questions? Now I'll move on to the next one. All right. Okay, I don't know what the heck I was doing here. I'm going to delete all this. All right, so this will be a multilinear example. So I have quantity sold. So this time is going to be more general. I'm not telling you it's umbrellas or what. I'm just telling you the price of some item. I'm telling you how much money I spent on advertisement. And I'm telling you how much I sold. So what do you guys think is the dependent variable? The Y variable.
Y will be the quantity sold and X will be the advertisement.
Yeah, that's for sure true. But we have another X, right? So you have two sets of X's. In other words, two factors that impact quantity sold. So this is still Y, but we have X1 and X2. So this is going to be a multilinear regression compared to the last one where we only had one X. So let's try this out. So I'm going to go back home. Where's my data thing? Oh, sorry, data. Click on data. Data analysis again. I'm going to do regression one more time. This time I'm just going to clear this. Make sure the labels are on so I can highlight the labels. So the Y one we all agree is quantity sold, right? Oops. Now X value. It's going to be two of them. Let's see if it lets me highlight both at the same time. I hope so. Output will be right there. Residuals, plots are on. Okay. So that should work. So I'm going to hit OK. Sure. Okay. Alrighty. So we have a multilinear regression right now. Let me check something really quick. Yeah, should be good. Okay. Now, so see how we have two factors now. Before, on the other example in rainfall, we only had rain. But now we have two factors and the intercept, of course. So I want to highlight the important stuff. Don't forget R squared. Okay, residuals. This is stuff I care about right now. Okay. So p-values, another thing we need to talk about. So p-values are basically the smaller they are, the better. You see how this is really small, so that means that this is a good value. This is relatively small, so the price coefficient I think is good. Advertisement coefficient might be good. Depends on my tolerance. So you can choose a tolerance in your stats and analysis. Like for example, you could say I will only accept a significance of 99%, meaning in order for it to actually succeed, it has to be it would be very strict basically. It would not accept anything, or it would actually remove things. Now, this guy set up to 95%. So as long as these are less than 0.05, I would trust that they're good. As long as this is below 0.05, then it's good. But to keep it simple, just make sure it's really small, and that means it's good. But anyway, so this equation is going to have an A, B, and C. So 3 different variables. So basically, it's going to look more like, let me open another text box. Okay. Kind of look like this. So you have a y estimator variable equal to A x1 plus B x2. Maybe I'll use capital. B x2, and then C constant. So you have your x1, which will be like one of the factors, could be price. X2 will be the advertisement. Or, sorry, rephrase that. So, yeah. A and B will be estimated by the regression. So here are the ABC. Okay, so how exactly am I going to set this up depends on, it's really up to us, honestly, which one we call A and B, etc. So let's put our estimators right here. But before actually, you know what, let's calculate them ourselves. That way we can test if they're right. So for A, I'm going to say it's going to be price. So equals price. Enter. B, I'm going to say is the next one, advertisement. C, there's no question, it has to be that guy. So I'm thinking it's like this, A, B, and C. And if I'm wrong, we'll know in a second. So I'm going to create the equation. So y equals, right, or just equals because it's a function cell. Just type equals. So I'm going to use A, which is the one for price, right? That's what we said. No, advertisement. A is advertisement. Okay. So, no, I think I retyped that wrong. Let me fix that. A will be advertisement just because it starts with an A. I'm going to change this up a little bit. B will be the next one, price. C did not change. Okay. Get back to here. So equals, right? It's going to be price, advertisement, times the coefficient of advertisement, this guy, plus, yeah, that's right, sorry. I have it all dyslexic in my head now because I didn't put them in the right order. It doesn't matter. B, we said was price, so there it is. And then we're gonna add this number here. Okay, now, is this the predicted value that they found for the first data point? So 8523. Yeah, that's what they got. So we did it correct. So now we can drag this down and have it create a function. But what happened, right? Remember we talked about this last time. We need to fix these guys. These are coefficients. We only want them to cycle through these, not those. So for every piece here, we can do it on the original, I guess. So for B11, that will be a fixed. All the 11s will be fixed. So now when I drag it down, those should not change. These should match up with this. Yeah, this thing. Okay, so we were right. This is ABC. Put some more information here, just so I don't get confused. Advertisement for ad coefficient. This would be the price coefficient. This would be the constant. I know that technically this row doesn't match up, but now that I labeled it, we should not confuse that anymore. Okay. So we're able to predict. So now we can also say, you know what if I spent, I don't know, 4,000 on advertisements, and I put my price at $1, right? What would happen? It looks like I predict to sell 10,000 items. So the amount of selling went up because I increased advertisement and decreased price. So logically, I should sell more if it's cheaper, right? And if I told everybody about it. If I told everyone, hey, I'm giving away umbrellas or whatever the hell we're selling, I should be selling more of them. So yeah, that makes sense. But this is the idea behind regression. So you take factors that affect or impact something else, you do an analysis. We're not going to get into the difficult or complicated statistics and how this works. What I want you to be able to do is call the function and read this table. So can you find the coefficients for the function, right? ABC. And can you determine if the model is good? So this tells me that, yeah, the model is trustworthy. If this was too large, then you would not trust this as a predictive tool. You would say, you know what, if this was like, I don't know, too big, like 0.1 or 0.2, 0.2, I would say, yeah, this model is not a good predictor, and I wouldn't use it. This tells me that, yeah, there is a linear relationship, which means I should look into this model and see if it is, in fact, being impacted by price and advertising. Are there any questions on this example? And I'll send you this as well in case you missed something. You can use my final version here. Okay. This is an interesting example. So these are two things that have nothing in common, but that does not mean that a correlation does not exist. But this example will underline why we try to separate this idea of correlation and causation, right? You agree that me importing lemons does not cause car crashes. It doesn't make sense, right? Unless like I have a bunch of trucks on the road running people over, selling lemons, and maybe, but these two things are not related, is what I'm trying to say. But you can still run statistics on them and find that there is a correlation with a good R-square value. Say that, you know what, that doesn't make sense, but that does happen, which is why I need you to remember when you're doing statistics, make sure you know. So let's see here. I'm going to do lemon imports as my Y, crashes as my X, and I'm going to output to there, I guess that's fine. So check this out. I have a really good R square, which shows that there is a correlation. But that's nonsense, right? See how the F value is good, which tells me that, yeah, this is a good model. I should be able to predict crashes with lemons. Like, what? What the hell are you talking about, right? Makes no sense. So when you're reading statistics or you see some data posted online or whatever, you need to understand, like, okay, the things you need to look for so you're not fooled by stats is where did they get the sample? Did they get the sample appropriately? And is it truly random? If the sample is not appropriate, then, and by sample I mean the data itself, the data is crap, then you cannot trust anything that it outputs. Okay. Like for example, if you were to, I don't know what's going on right now. Well, let's talk about football, I guess, right? If you were to take a sample, data sample, right, of just Dallas and asked, is the Cowboys the best team ever? I'm pretty sure that sample will be biased, right? Or, but if you ask the entire United States or a sample that better represents people who like football, then that response will be different, right? Or same thing with like politics, right? If you focus on a certain part of town and ask them who's the best president versus a different part of town, they're going to say different things. So it needs to be a sample that represents the population, a proper sample. Otherwise, it's just BS. And another thing is, if you do see a correlation between two things, that does not mean that one caused the other. So you need to, that just says that you should look into it if it makes sense. Obviously, this does not make sense, so we're not spending any more time researching lemons and car crashes. I would just say, okay, that's weird, and move on. Right? I don't think we have time for these guys, but here's an interesting example, just if you want to mess with it later on your own. This is sex is 2, we'll say is female, 1 is male, right? We have 20 people. We have IQs of these 20 people. We have the volume of their brains, the surface area, the circumference, and the weight. So you can use these as all you can use these as a multiple linear regression to see if factors of sex, volume, area, circumference, and weight, do all these things impact IQ? So you can figure out, okay, these guys smarter because the brain's bigger? Are they smarter because they have more surface area or more volume? Or is it males or females smarter? So you can have all these things measured, and you can see which factors are significant. So that's another thing that you can think of. So like we go back to let's see, cells, right? If we look at the factors, notice how price has a smaller p-value. So this guy may have it might, I'm not saying it does. This may have more impact on selling. So the price seems like it has a bigger impact on the model. This kind of makes sense, right? If something's cheaper, more people are going to buy it, right? It's just basic economics. Advertising does have an effect. We all know this, but which affects it more? I would say price, and that's what this is reflecting. So if you were to do this brain example on your own later, you will see that maybe some of these have an impact on IQ, or maybe none of them do. So you'll look at the p-value, and you'll see that, oh yeah, maybe it doesn't, maybe it does. So when you did the regression earlier, before I let you go, see how it has a 95% automatic? So that's kind of your tolerance level. So you're saying that we will consider anything significant as long as these p-values are less than 5%. So I will only accept 95% confidence. Okay, so I'm 95% confident that this is legit. So if any of these values go above 5%, in other words, 0.05, I would consider them insignificant. Meaning, if price was 0.2 right here, I'd say, you know what? I don't think price has any impact on me selling this stuff, quantity sold. So that's how you can determine, like when you're doing like research or like you're doing this for a living or something, you're analyzing data, you say, you know what, I don't think this has any impact, and we should maybe, or like if advertising didn't really have a big impact, you might say, you know what, for this particular product, I think we should spend less money on advertising because the impact on the predictor isn't that great. Anyway, you guys have any questions in general?
No questions.
All right, before you go, it's about time. Let's see if I can bring up the homework real quick. Okay, you guys see the Word document? Yeah, okay, good. All right, so what you're gonna do is find the regression line of for the data. So the first thing you would do is put this into Excel, right? So you have the table gives Olympics pole vault records. So this is the height over the years in the 20th century. So it's doing the vault. So in the 1900s, this was I guess the record at the time. As you can see, in 2000, it's 5.9. So there's been a pretty big difference over the years. So the question will be, okay, what is the regression line for the data? So you put the equation here. And then it'll say, all right, what's the p-value for, is it a good model? So remember how we said, look at that F statistic? You'll say, all right, F is pretty low, so yeah, it looks like a good model. And you'll say, when you write down that value, p-value, or the F stat value. Then you write down the R value there. And then I'll tell you, is there a linear relationship? You'll say, yeah, based on the R square being close to 1 or -1. If it's close to 0, or then no, it's not a linear relationship. And then you do like a scatter plot. So I'll show you real quick. Almost out of time, but you can do a scatter plot function to see what it looks like. Or like when I click that little button to do the fitted line, that also does it for you automatically, so you don't have to do the scatter plot. Let's see here. And once you have the equation, like we did earlier, you can predict what happens in 2010, right? You can just plug in a number into your equation here. So that'll be part 2004. That'll be part C. So plug in 2004 and find out what happens. Okay. Right, and this will be similar. Put these both into Excel, do a scatter plot, and then try to do a little sketch here. Does not have to be perfect. Write down the R value and determine, is there a linear relationship? This is not too bad. Okay, and then write down the F stat, or find out if it's a good model, and put the equation of the model here. The Y equals AX plus B, right? Anyway, these are all similar, practice over and over again. I don't think I see anything harder. Yeah, they're all just simple linear, right? Just one factor, so one independent variable, one dependent, one factor, one predictor. Okay. All right, guys. Well, that's all we have. That's pretty much all the time we have. You guys have any last minute questions before we head out? I'm gonna save this. All right, here's the Excel file that we just did together. So if you missed something or went too fast, here are the examples. And this is the stuff I just did. And the first one is the blank one. The blank and non-blank. All right.